I have introduced inventory management system in the previous video. Now, let's understand something more about the inventory control system, stock control system, or inventory management system. What does it mean? What are we trying to do is to ensure that whenever a particular material is needed, maybe a raw material or consumable, is available. That is the only thing. You have a customer is demanding something, you must have that thing with you. This is inventory management. Okay. So, inventory control system minimize the following three cost categories. One, inventory holding cost. You are not having more than required inventory. Ordering and shipping costs. You are not buying frequently, very frequently. If you are buying very frequently, then your ordering cost or shipping cost to the warehouse or the store will go up. And three, cost of storage. If you are storing more, then the rentals, then the risk involved with the storage will go up. I know that you have studied all such aspects in cost accounting or the management accounting in your some other paper. That's why we have something known as safety stock. What is the safety stock? Safety stock is needed in case of unexpected events such as spikes in demand or longer delivery times. It's a seasonal thing, or all of a sudden something has erupted in the environment. Because of that, you have extraordinary demand for a particular thing. So, you should have safety stock, that I'll be able to handle this situation because I have something with me which is termed as safety stock. We have another term in inventory management is known as just-in-time inventory. What is this just-in-time? Deciding when to order and how much to order is used to answer both questions in economic order quantity model, taking all costs into consideration. JIT inventory management, just-in-time inventory management, attempts to minimize holding cost, meaning thereby that whenever I need something at that very moment, the thing should be delivered to me. Just in time, I need this raw material right now. At that very moment, raw material will reach my factory. This is just in time. By not taking positions of inventory until it is needed in the production process. This leads to something known as lean manufacturing systems. This leverages suppliers delivering small lots on a daily or frequent basis, that is JIT, and production machines are not necessarily run at full capacity. I need to produce only this much. I'll place the order for the raw material for this production, this much production only. Unnecessary production is not happening. Unnecessary raw material is not being procured. This all is lean manufacturing. Empowers workers so that production decisions can be made by those who are closest to the production processes. Then friends, whatever is being produced should be checked. For this we have something known as QC, quality control systems. What do we understand by quality control systems is standalone maybe or part of enterprise-wide TQM, total quality management effort, for providing data about the quality of incoming materials or parts as well as the quality of in-process semi-finished and finished products. If you want to have a good quality output, then you should have good quality input and good quality processing. So this total quality management system should get activated at the very moment when the order for a raw material is being placed, and then when the raw material is being received, and then when the raw material is being processed, and then when the finished goods are being received by the warehouse or the produced by the machines. So data collection by sensors or RFID and interpreted in real time or stored in the database for future analysis. This should happen in a real time basis. It should not be treated as post-mortem, that the thing has happened and now you are doing TQM activity. If it's happening like this, after production you are checking the quality, then the whole batch of the production will go waste. So friends, for this we may use something known as CIM, Computer Integrated Manufacturing. Everything is being controlled, managed with the help of CIM, Computer Integrated Manufacturing. Computer Integrated Manufacturing helps us to control day-to-day shop floor activities. Shop floor means factory. To replace disparate information sources, frequently late, unreliable, voluminous, and extremely difficult to assimilate. If the information is not being captured at that very point, at that very place where the production is happening by CIM, Computer Integrated Manufacturing, then we will be late to take a call. So, without delay means frequent late. Without making it unreliable means it should be reliable. Without making it voluminous means whenever it's happening, let me capture the data. And making it difficult to assimilate, I must capture the data and start assimilating. So, for this we have Computer Integrated Manufacturing. One part of this is Manufacturing Execution Systems, MES. Friends, in different books or at different organizations, you may find different nomenclature, but that doesn't matter. So, what it does, this Manufacturing Execution Systems is manage operations in shop factories, sometimes a few critical machines, sometimes all operations on the shop floor. Typically, broader infrastructure than CIM. At times, it may be a part of CIM. At times, CIM may be a part of it. It depends upon the way in which you perceive it. Based on standard reusable application software instead of customer designed software. This is something new for us. This we must know that in manufacturing execution systems, what is happening? That you have readily available modules and you will be using such integrated modules in a fashion so that it may work in a perfect manner. So with the help of readily available small softwares, we may create it. So it is reusable application softwares instead of customer designed software. We may have something known as FMS, that is Flexible Manufacturing Systems. They can accommodate manufacturing of different parts at different volumes. What are the benefits of CIM? It simplifies manufacturing technologies and techniques. It automates as many of the manufacturing processes as possible. It integrates and coordinates all aspects of design, manufacturing and related functions. And then friends, at the end of this section, we have questions.